Hello, everyone. My name is Miti, and today I'll be presenting our project Mitigator that I've worked on with Professor Ian Goldberg from the University of Waterloo. So we all know about how privacy policies are really hard to read. And on the other hand, users have no way of knowing whether the company collects and processes its data in compliance with the privacy policy. So for example, earlier in the summer, Zoom's privacy policy did not reflect its sharing practices. Zoom was found to be sending users location data and device identifiers to Facebook when the privacy policy did not mention this sharing behavior. So no more will you need to say, well, we don't really know if the website's doing this bad thing with our data. Uh, Mitigator will check the code and verify it that you can't see, and we will tell you if that code is being compliant with the website's privacy policy. So we have several goals for our system. First, we do not want to share proprietary server-side code. So we support this through a check that is plugged into the build pipeline of the website. This setup effectively complements existing testing benchmarks at Consumer Reports, which glean data processing practices of the organization from publicly accessible information, such as through traffic analysis. Second, server-side platforms and machines may be buggy. We only require users to trust a small hardware platform within the OS to be free of vulnerabilities instead of the entire machines. For our prototype, this is the Intel SGX platform. In this sense, we move away from solutions such as seals that simply audit the software and trust the OS to be free of bugs. Third, users should be able to know how their data is actually being processed by websites. So by itself, the user-facing part of our product can also be used to just show how privacy-friendly a privacy policy is. And finally, we want to help the organization have compliant policies and code. So for instance, if it refines the privacy policy from A to B, but does not make the appropriate changes in the code, then our product should be able to catch this and alert developers to fix the code to reflect version B of the privacy policy. So we develop a system that includes both server-side and client-side components to ultimately ensure that users' data is handled in compliance with the privacy policy. At the heart of our product, we run a verifier on the server-side platform that takes as input the website source code and the privacy policy. It compares the two for compliance. This is essentially the part of our system that I mentioned earlier that plugs into the organization's build pipeline. Apart from the verifier, we also run a few other programs on the server-side platform, which are shown in red here. And of course, there's the website itself, and then we have a decryptor program. Beforehand, the client indirectly authenticates the decryptor and that the website has been checked by a valid verifier. Once the user fills out a form, the client forwards its personally identifiable information in encrypted form to the decryptor. And it passes through the website, and the decryptor only hands over plain text PII to a target website that has been verified by the verifier to be compliant. All of these programs run within the Intel SGX platform within the OS, so we don't need to trust that the entirety of the OS is free of bugs, and we're going to focus on the client's browser extension. Here we want to show a positive signal to the user when the code and policies are compliant, and we want to address the case when both the privacy policy and code are compliant, like in the example here, but both are sort of, really privacy invasive because your data is being shared with third parties. So let's go through the steps and take a deep dive so as to how we build a privacy score out of a privacy policy model. We obtain a privacy policy model of a site using existing tools. So it starts with the privacy policy, generates the model. The tool that we use is Policies. We look at data collection and sharing practices. These are the ones that we can currently verify. And so we arrive at a model like this, where for each information type, so here we have financial data and contact data. We know why and how it's being collected. And we also know who it's being shared with and why. So for each field, for example, the information type and the purpose of use, we assign the value of the field with the score depending on the sensitivity. So perhaps sharing your health data is more sensitive than just sharing how you're interacting with the website or your mouse traces. And not sharing items gives an information type a better score than sharing items, and not collecting an information type at all, gives that gets an even better score. And so finally, for each information type, we have a final score that is made up of weighted scores of all these different fields, such as the purpose of use, how it's collected and shared. And so here in this example, we have three different types and of information, three different information types, and this is for a financial website. And so a financial website collecting health data is a little fishy, and so we have that a low score, and again the source score from low to high, from 0 to 100. And each of them is assigned into a category. So health gets into a red category because it's kind of scary. Contact information is being shared, so it's a little sketchy, but a financial website collecting financial information kind of makes sense, so it's green. And just to give a demo of our system here, we have, for myfavoritebank.com, we have 6 different information types that are being collected, as you can see. And let's focus on the red one, health, because that's a little scary. And here we can see that it was actually collected from a third party, and it was to provide some additional service that that financial site or that bank provides. And even though the data is not being shared, Mitigator still gave it a low score because it's kind of unexpected to use health data for a financial site. And for the contact information type, we see that it is being shared with a third party for a given purpose, and Mitigator gave it an intermediate score of 45 to this practice. And since it's kind of not too bad. And then here for location data, it's in blue because your bank does not collect your location data at all. So that's great, and Mitigator gave it a score of 100. For our next steps, we hope to improve this extension and also work with CR on more of the server-side components. Specifically, we would like to refine the Verifier component to check different data processing practices for a simple website's backend. We would also like to implement an authentication services to basically offload some of the authentication work that each user's extension would have to do otherwise.